So first of all, we want to be able to write the component or linear combination form if we're given a magnitude and a direction angle. So that's our first thought. So we are given a magnitude and we're given a direction angle, and we want to be able to come back and decide what is this vector v going to be. Okay, so let's put some numbers with this to kind of understand where this is coming from. Okay, so let's say our magnitude is 9. And what's your favorite angle? 30 I heard first, so our angle is 30. Although 45 came in a really quick second. Okay, so let's say that we have a magnitude of 9 and an angle of 30 degrees. That means that we're saying at 30 degrees, we're coming out here 9 units. Okay, and we want to get the component form or the linear combination form of this particular magnitude and direction. Okay. So how can we figure out what this A and what this B are? Okay, good. We can do cosine and sine because, right, this is my A, right, and this is my B. A is the adjacent, right, to 30. We have a hypotenuse, right? So if I want to figure out what A is, I'm going to use the adjacent hypotenuse, the ka of SOHCAHTOA. So the cosine of 30 is the adjacent over the hypotenuse. So how would we solve that for A? Yeah, multiply by 9. So 9 times the cosine of 30 would be equal to A. How would we find B? What? So once we had A, we could use the Pythagorean's theorem to find B, but let's use the same idea. How is B related to 30 and 9? The sine of B of 30 would be equal to the opposite over the hypotenuse, and we want to get the B by itself. 9 times the sine of 30 would be equal to B. So let's write this in a more formal state, right? That works for everything, a formula type of thing, as opposed to our particular numbers that we chose to use. So if we want to find the direction or the vector, the component form, when we're given a magnitude and a direction angle, you said that to find the horizontal component, we take the magnitude times the cosine of the angle. And when we want to find the vertical movement, the vertical component, we take the magnitude times the sine of the angle. Make sense? Okay. Got that down there in this big old mess, so we'll leave it out for the moment. And if we wanted it in the linear combination form, then we simply say magnitude of V cosine theta I plus magnitude of V cosine theta j. So if we want the top one to be in component form, then we use our pointed brackets, and we list the horizontal movement, and then we list the vertical movement. And we found that by taking the magnitude times the cosine of the direction angle, or the magnitude times the sine of the direction angle. Make sense? Yeah, the bottom one's the linear combination. So we have like square root of 3i plus 2 square roots of something j, or whatever. Okay? So far so good? All right, so here comes the next one. we want to find the component form of vector v. So now we're going backwards, right? Because vector v has a magnitude of 2, and it has a direction angle of 45. You get to use your 45 anyway, Savannah. And we want to figure out what is the component form of this. In other words, what pointed brackets are going to contain what two values, what horizontal movement, what vertical movement. Okay. So we said the horizontal movement is going to be what? Yep. So we'll have a 2 times the cosine of 45 and 2 times the sine of 45. What is the cosine of 45? So if we take a square root of 2 over 2 times 2, we're going to get what? Plain old square root of 2, right? Same thing with the sine of 45. If it's one of our primary angles that we know, the 30s, 45s, and 60s, and their multiples, then we want to keep them in radical form. But if it's something that we don't recognize, then by all means we'll use decimals. Yep, because of this 2, that's going to cancel out the over 2, and we just get plain old square root of 2 and square root of 2. So far, so good? Okay. Part B says, now I want you to do the same thing. Tell me what the component form is, but this time we want to tell you that we have a direction, okay? So we have to find the angle first, okay? Then we'll take 3 times the cosine of that angle and 3 times the sine of that angle to get our component form. So how are we going to find the angle, the direction angle, if we have negative 3I plus 4j? So let's sketch it out. If we're at negative 3I, that's 3 in the negative horizontal direction, right? And 4 in the positive vertical direction. So our vector's going here. So how do we find this theta? Because theta is always, always, always from the positive horizontal axis, right? Always starting here. Yeah. Find this little angle right here, right? And then subtract it from 180. Okay? Well, the cool thing about this is I think we don't even have to go quite that far, right? Because we know that this is in the direction of 3 and 4, right? But we know it can't be that long because it's only supposed to be 2 long. How long would this magnitude be of this particular vector? 3, 4, 5, a 3, 4, 5 right triangle, right? So it's too far out there. We only need it to be 2, so it's going to be only about this far, right? Because they said that I'm sorry, 3. It needs to be 3. My fault. I was looking at the last one. So it needs to be 3 in length and magnitude, but in the same direction. And so this is too far. This is 5, so it's going to only come to about here, right? And so we want to figure out what that is. Okay? Well, we know what the cosine of this guy is, don't we? The cosine would be the adjacent over the hypotenuse, right? So 3 over 5, the cosine of this theta. call this theta prime. Adjacent over hypotenuse, right? And the sine of this theta prime is going to be what? Okay. So, I guess we can add our negative there if we want to. So we can say, guess what? Should add our negative there. Then the component form of this guy is going to be our magnitude times the cosine of theta prime, which is negative 3/5. And then if we want the vertical movement, we're going to say the magnitude times the sine of theta. Okay. So what is negative 3 times 3/5, or 3 times negative 3/5? And what is 3 times 4/5? So that should be the component form of a vector in the same direction that has a magnitude of only 3. Should we verify that it has a magnitude of 3? We would simply take the sky and square it, plus this sky squared under the radical, right? What is 9/5 squared? 81/25. 12/5 squared is 144/25 for a total of 325/25. What's 325 divided by 25? 320. Oh, sorry, 225. Sorry, 225/25. And what is the square root of 225? 15. What's the square root of 5? So we get 3. Okay. So as long as we're in the same direction, right, we only pull the direction off, and then we multiply it by the magnitude to get the right vector. Make sense? We don't even have to find the angle, okay, because we only really need the cosine of the angle, right? We could have found the angle by using this inverse tangent, right? And then 180 minus this guy would get us the angle. But we really only needed the cosine and the sine, and we can look at it and see what the cosine and the sine are. Question? We just wanted to check to verify. We didn't have to do this part. Yep, we're checking to make sure it works. So this was just our check. Okay, the magnitude was given, so we wanted to verify that when we were all said and done, that this was actually going to become that magnitude that we were looking for. Okay. Other questions? Yep, this is your final answer for this one. Unless they wanted it in linear combination form, it would be negative 5 9/5 I plus 12/5 j. So far, so good? All right, great questions. Here comes the next one. Now we want the component form, same form, of the sum of two vectors U has a magnitude of 4 and a direction angle of 60, and V has a magnitude of 5 and a direction angle of 90. So how are we going to find U plus V? Well, how did we find U plus V yesterday? Absolutely, we need to find the component forms first. Then it's very easy, right? We just add the horizontal movements and add the vertical movements and we have our answer. So how do we find the component form of U when its magnitude is 4 and its direction angle is 60? For cosine 60, right? And for sine 60. All right, so 4 times the cosine of 60. First of all, what's the cosine of 60? 1/2. And 4 times 1/2 is 2. 4 times the sine of 60. What's the sine of 60? Radical 3 over 2. If we take radical 3 over 2 and we take that times 4, we're going to get 2 radical 3, or 2 square roots of 3, aren't we? Okay. Now let's find the component form of vector v. Okay, to find the component form of vector v, we're going to take 5 times the cosine of 90 and 5 times the sine of 90. So what's the cosine of 90? 0. Anything times 0 is. And the sine of 90? So 5 times 1 is 5. So now we're ready to add them up. And u plus v will be 2 plus 0. And 5, let's put 5 plus 2 square roots of 3. But if you wrote 2 square roots of 3 plus 5, that's perfectly fine. And since we knew those numbers, we want to keep them in radical form, the exact values. Make sense? Questions do you have on this one? Okay. So here's how we apply vectors. This is what you've been doing in physics class. We're told that we have 2 vectors, 2 forces. One with a magnitude of 2,000 newtons at 30 degrees, and another with a magnitude of 900 newtons at a negative 45 degrees with respect to the x-axis. We want to find the direction and the magnitude of the resultant of these 2 forces. So first of all, what did we do a moment ago when we wanted to add 2 forces together? Or 2 vectors together? It might be easier if we see that u is, and we like to boldface them, it's hard to do when you're drawing. The magnitude of u is 9,000 or 2,000. And the direction of u is 30. Magnitude of v is 900 at a negative 45 degree. See how math makes things much simpler? At least the math symbols do. All right, so what are we going to do? Find the component forms. Okay, so easy enough. We'll have 2,000 cosine 30 and 2,000 sine 30. So what's the cosine of 30? what's the sine of 30? Cosine of 30 is root 3 over 2, right? Square root of 3 over 2 times 2,000 is going to get us 1,000 square root of 3, and 2,000 times the sine of, so 2,000 times 1/2 is 1,000. Okay. Now let's find our other one. 900 times the cosine of negative 45. 900 sine of negative 45. What's the cosine of a negative 45? Positive or negative? Here in both, 45 degrees negative means we're going to the fourth quadrant, right? So the cosine is positive. So we'll have a square root of 2 over 2, right? Times 900, which will be 450 square root of 2, if I can write my 4 without trying to change it into a 5 right away. And 900 times the sine of negative 45. So negative 450 square root of 2. All right, we're ready to add them. So when we add them, our horizontal component will be, doesn't matter which one you put first, right? 1,000 square roots of 3 plus 450 square roots of 2. And the vertical component will be 1,000 minus 450 square root of 2. So we did the heavy lifting now. We have it in component form. But what did the directions ask us for? The direction angle and the magnitude. Okay? So we can find the magnitude by using a squared plus b squared under the square root symbol, right? And we can find the direction angle by using what? Inverse. We want to find the angle, right? So let's think about this. Let's just pretend this is 4 and 5, right? Okay, or something like that. So we want it to be, it was going 30 degrees a long way, or with a lot of force, and negative 45 degrees with not as much force, right? So our angle is going to be somewhere over here, isn't it? Maybe probably a little bit in this direction, maybe further. Hard to tell for sure, right? So what are we looking for? If this is our A and this is our B, what are we looking for here? How are we going to get that angle? Opposite adjacent, right? We're using tangent here to get our angle back. Like we said yesterday on our direction angle, we're using the inverse tangent to find the angle back. Okay, so we need to put this stuff in our calculator. And we need to have a good place to store it so that we don't have to type it over and over and over again, because that's messy, isn't it? And we don't want to lose any decimal places if we can help it. Okay, so break out your graphing calculator. I'll show you how to store things. All right, so we want to take 1,000 square roots of 3 and we want to add 450 square roots of 2. And when we do that, we end up with 2,368.44, so forth, right? Okay, let's store that into a variable. So we have all these little, in my case, teal letters, A, B, C, D, E, F, G, H, I, J, K, and so forth, right? So these are all placed that you can, it's an alphanumeric key that you can store this value in. So your store button is next to your 1, to the left of 1. We're going to store this number in to alpha A. So that will be our horizontal component. We press enter and it says, hey, I just put that in A for you. Okay, let's do the same thing with B. Now we want 1,000, or with the vertical component. 1,000 minus 450 square roots of 2. So we get 363.6 roughly, right? We're going to store this. So by the first, store into B. And the calculator says, I just stored 363.6 and so forth into B. Okay? Now we won't have to do this again, right? Because now when we want the magnitude of our resultant vector is the square root of A squared plus B squared, right? And even if they're nasty numbers, we can still do that. So we just say, hey, guess what? I need to know what is the square root of that A, alpha A, that I just plugged in, right? Squared. I need to use my squared button. Plus alpha B squared. And if you have just a scientific calculator, oftentimes they have places that you can store these things too. So it doesn't have to be a graphing one. The scientifics are getting really nice. All right, so we're taking the square root of A squared plus B squared. Did everybody get 2,396.2? Okay, so 2,396.2 newtons is our magnitude. And now we've got to find our direction. Okay, to find that direction angle, we need to take the B over A, inverse tangent, right? Inverse tangent of B over A, because the B is always your sine, right? The Y value is your sine, the cosine, sine over cosine, okay? So we're taking the second tan of the B, alpha B, divided by alpha A. So what's the inverse tangent of this? 8.73 degrees to 2 decimal places. And we're done. You only have one of these problems. I think it's the very last one that you have to do. Okay? On your assignment. Yep, today. But you can see that those are handy buttons to have, right? And it's good to store. Question? So to get this one, we said we would need to take the B divided by the A, because we know those two, right? And then inverse tangent. So inverse tangent of B over A. Okay? So far, so good? All right, last example. This one's a lot shorter. Okay, velocity. So it can be a force acting on an object in an angle, right? We can also talk about a velocity, a speed of a pitcher, speed of a gun, of a bullet, right? And so we want to figure out what the vertical and horizontal components of this velocity of a gun that's firing 1,200 feet per second at an angle of 6 degrees with the horizontal. We want to find the vertical and horizontal components. So think about your 1,200 feet per second as your magnitude. Okay? And think of the angle of 6 degrees as your theta. So how do we find the horizontal and vertical components? Yeah, we use that formula, right? That we derived. We take the magnitude times the cosine of theta to find the horizontal component, and the magnitude times the sine of theta to find the vertical component. So 1,200 times the cosine of 6 will be our horizontal, and 1,200 times the sine of 6, and we don't know this one, so I'm hoping you're getting out your calculators, is our vertical component. So 1,200 cosine of 6 is what? What was it? Feet per second. And 1,200 times the sine of 6? 120, I was going to say 4 seems high. 125.5? 4 feet per second. Okay, makes sense? So we're never going to outrun a bullet, right? Or even dive to the side. When they're asking for horizontal and vertical, you could put them in component form. I'm not going to count it wrong. But they're just asking what's your horizontal movement, what's your vertical movement. Okay. Crazy fast, right? You don't have a chance. Because this how your distance and yeah, and whether you have a head start.